Now we're going to have a quick look at aldehydes and ketones, the key features of these families of organic compounds, and also some of the key reactions that they undergo. The functional group in both aldehydes and ketones is the carbonyl group. The difference between an aldehyde and a ketone is the placement of the carbonyl group. In an aldehyde, the carbonyl is in the terminal position. That means that it is on the end of the chain. In a ketone, the carbonyl is within the chain. So basically that means that the carbon component of the carbonyl is attached to two separate alkyl groups. Now the suffix when naming an aldehyde is anal, so the prefix is just the alkyl component, that is the number of carbon atoms, followed by anal. So for example, if we had an aldehyde with 3 carbon atoms in the chain, it would be propanal. Ketones, however, have the suffix of anone, again the prefix being the number of carbon atoms in the alkyl chain. So that's the whole chain, so all the way through there, the longest chain. So if we had a ketone with 3 carbons, for example, it would be propanone. Both aldehydes and ketones can be prepared through the oxidation of an alcohol. The oxidation of a primary alcohol is going to produce an aldehyde. During this process, the aldehyde that's produced will need to be removed from the reaction mixture so that it doesn't undergo further oxidation to form a carboxylic acid. A secondary alcohol will undergo oxidation to form a ketone. This doesn't have the same requirement as the aldehyde of needing to be removed from the reaction conditions as it's produced, because the ketone cannot be further oxidized. The fact that an aldehyde can undergo oxidation while a ketone does not undergo oxidation can be used as a means of distinguishing between the two. On addition of an oxidizing agent to an aldehyde, we'll be able to observe a change as that oxidizing agent is reduced. With a ketone, however, if we add an oxidizing agent, it will not be reduced, and therefore we won't observe any change. Now an aldehyde can be oxidized in both acidic or alkaline conditions. Depending on what conditions there are will determine what type of product is produced. In acidic conditions, the aldehyde functional group, or the carbonyl, will be oxidized into a carboxyl, producing a carboxylic acid product. The reagent used for this is acidified dichromate. And during the process, the dichromate ion is reduced to the chromium 3+ ion. The dichromate ion is orange in colour, whereas the reduction product, the chromium 3+, has a green colour. So the fact that oxidation and reduction has occurred, is the observation of a orange to green colour change. So just to recap that, in acidic conditions, such as using acidified dichromate, an aldehyde will be oxidized into a carboxylic acid, and the observation will be an orange to green colour change. This can be used to distinguish between an aldehyde and a ketone, because if we add our acidified dichromate to an aldehyde, we will observe the colour change. If we add our acidified dichromate to the ketone, we will not observe a colour change because there is no oxidation and hence no reduction. Under alkaline conditions, an aldehyde will be oxidised to produce a carboxylate ion. An example of a reagent that produces alkaline conditions is a mineral called silver nitrate, or more commonly referred to as Tollens reagent. During this reaction, the silver ions are reduced to a solid silver deposit. So the observation is the formation of the precipitate. Now the silver that is formed generally deposits itself on the inside of the glassware being used, so it appears as a silver mirror. So this particular test is often referred to as the silver mirror test. So just to recap, alkaline oxidation of an aldehyde occurs when we use a reagent such as Tollens reagent. In these conditions, the aldehyde will be oxidised into a carboxyl ion, and our observation is the formation of solid silver in the form of a silver mirror. So if we were to add Tollens reagent to an aldehyde, we would observe the formation of a silver mirror. If we were to add Tollens reagent to a ketone, there would be no precipitate because the ketone would not be oxidised. So just quickly recapping, we've had a look at how both aldehydes and ketones contain a carbonyl functional group. What distinguishes the two is the placement of that carbonyl within the structure. Both aldehydes and ketones can be produced or prepared by the oxidation of an alcohol. So oxidation of the primary alcohol will produce a ketone. Oxidation of a secondary alcohol will produce a ketone. Aldehydes and ketones can be distinguished between via oxidation, because an aldehyde will undergo oxidation whereas a ketone won't. And two reagents that are commonly used to test that, so to test the presence of an aldehyde or a ketone, is acidified dichromate and Tollens reagent.